Now, let us come to the glass processing of IGU. What we basically have, the starting is a washing machine. It can have 3 or 4 pairs of brushes. Okay, coming back to this, you have a washing unit, you have a drying unit, you have a spacer conveyor, you have a butyl extruder, you have a pressing unit which is normally vertical. Okay, now let us come back to washing. It is almost the last process in a glass processing. Okay, so you need to have very clean surface before you make the IGU. So glass washing plays a major role in it. You will have cutting oil residue, you have small particles of glass which will be stuck on the glass surface. So that has to be removed, which is done by washing. Any finger marks which is from the operator, that has to be removed, which is done by a good washing machine. The glasses now move through the vertical washing machine, and it has got 2 chambers which has got a warm water as well as the normal room temperature water. Normally it has got 3 to 4 cylindrical bristles which touches the glass surface and cleans the surface of the glass. Normally the brushes are made of nylon. You also have polyamide which has been used for high end washing, and for low E or the soft coated type of glass, you have the 4th pair of bristles which is used to clean the surface of water. It is very important that the washing machine should not have a greasy internal surface. To ensure that, change the water in the water tank every day, change the water in the final tank every week, and clean the entire machine with water once in a month. These are very good practices to be followed. This process takes approximately 3 hours. The machine also needs to be cleaned with hydrogen peroxide or RBS 50 once in 6 months. Now comes the measurement of water washing quality. We often feel, are we washing it properly? Is the glass come out washed right or not? So how do you determine the washing quality? So what you do is you take a drop of demineralized water, place it on a clean surface, on a wash surface, and then see the angle of the drop. If the angle of the drop is almost like 90 degree, the glass is said to be very dirty. You can see in the image, when the angle is almost like 90, it is the glass surface is really dirty, and if the angle is greater than 25 degree, the glass is considered to be still dirty, and if the angle is less than 25, then the surface of glass is said to be clean. Another test which can be used is a chalk method. Apply wax chalk on the surface of the glass and pass the glass through the washing unit. If the chalk marks remain on the glass, it follows that the machine will have to be cleaned and the water is to be changed. You can see the image on the left hand side, you can see the chalk marks still left on the glass surface. On the right, you can see it is very clean surface. Now comes the drying and inspection area. Once the glass is washed, it moves onto the drying unit. You have knives in the drying unit. Air is blown over the glass with great pressure. There are air knives on the unit that helps to dry the glass. These air knives should be installed at an angle in order to clean the water in the opposite direction of glass movement. The glass then moves on to the inspection area where it is checked. You will have some light which is from the behind for making it easier for inspection. Now comes the frame manufacturing. Frame is nothing but a aluminum spacer which is bent. You can have either a corner key or you can have a bent spacer which can be used. The spacer material is cut to the specific size. The spacer bar is then kept at an angle slanting position to fill the desiccant. You can also have a automated machine where you can fill the desiccant inside, and that drilled hole is sealed with a primary sealant. We can see the aluminum spacer which is cut based on the dimensions which is required, and you have either the semi manual filling of desiccant, or you also have a automated way of filling the desiccant. You should have at least ideally 85% of the spacer bar which to be filled to give a life of at least 5 to 10 years of the DGU. Even though the desiccant is directly filled with the container, it tends to absorb moisture from the environment. So, the time between the filling of desiccant to the assembly to the unit has to be the minimal. The quantity of water absorbed by the desiccant before assembly is known as the I rate. The butyl is then applied on all the 4 sides of the frame using the primary sealant application machine. Just take care that proper gloves are worn by the operator, because otherwise the adhesion will be affected. As the frame created in this process has got 4 joints, the heat loss is considered to be more. To address this, the frame or the spacer is bent at 90 degrees and the frame is assembled with a joint. That is called a bent spacer. It is then sealed with butyl. The assembled frames are kept stacked on the spacer conveyor. Ideally, pressing should be done within 1 or 1.5 hours from filling, but it can go up to 3 hours. It is always ideal to hang the filled aluminum spacer with desiccant like a frame which is shown in the picture. This is a automated desiccant filling machine. Butyl temperature settings must always be less than the maximum temperature which is recommended by the supplier. Handling should be minimal to improve the adhesion of the spacer. Use only the fingertips when necessary and touch only the frame, not the butyl ribbon. Monitor the quantity and the continuity of applied butyl, that is very important. Monitor the frame positioning on the glass. Once the frame has been manufactured, it needs to be positioned. This is the only process which is manual in this IGU, and that has to be done very skillfully. The picture shows the skill which has to be applied, so that the bite is uniform for all the 4 sides. After the frame has been positioned, the glass goes through the next stage in the process, that of the pressing and the gas filling. The glass is now passed through the pressing unit. Pressing is done always vertical. The sides of the pressing unit are lined with felt which protects the glass from scratches. A pressure of 6 bar is applied minimum to have a better adhesion of 2 glasses. The inert gas that can be filled from the machine, or you can also have a semi manual machine as shown in the picture. Based on the volume of the DGU, you can fill the inert gas in it, either argon or krypton. The last stage in the process is sealant extrusion. The secondary sealant, mostly silicon which is used in our country, is applied on all the 4 sides. This provides mechanical cohesion to the whole assembly. In case of 2-part sealant, the mixing ratio base A and catalyst B should be consistent. Normally it is mixed in the ratio of 1:10 ratio, and this has to be of homogeneous mixture. You can either have it manual like the way it is shown in the picture, or you can also have a robo sealing, which is most ideal. Now, let us come back to the test which is performed on a double glaze units. The first test is the adhesion test. Take a glass sheet and fix an aluminum frame on it with the butyl. Try to remove it after 24 hours. If it does not come, the adhesion is said to be really good. Second test can be a butterfly test, which is most commonly done in our country. Put some silicone on a sheet of paper, fold it and then press it. Check the color of the mix, which indicates whether it has been mixed properly or not. The same thing can be performed by having two glass sheets and put the silicone in between, and if the mix is completely black as shown in the image, it means that the mixing is proper. This image you can see the mixing is not proper because you can see some white streaks, and while this image it shows the mixing is really good. Now, the next test, to check the regularity of the pump, measure the hardness of at several points on a bead on a periphery of the IGU and calculate an average of the data. You can have a Shore A hardness test, which is done on a secondary sealant after it cures after 24 hours. This is a Shore A hardness tester. Normally, the curing time recommended is 8 hours, after which the IGU is ready for use and transportation. One important thing is the traceability. We always need to have some traceability of the consumables which is used while making IGU. So, please have a logbook which will have all the records of the spacer used, the consumable used for making IGU. For low E glass, you have something called the edge deletion, which you might have heard. So, that can be done either in the IGU machine or in the cutting machine.